The Norwegian Current is a water current that flows northeasterly along the Atlantic coast of Norway at depths of between 50 and 100 meters through the Barents Sea Opening into the Barents Sea. It contrasts with the North Atlantic Current because it is colder and contains less salt, having most of its tributary water coming from the brackish Baltic Sea as well as the Norwegian fjords and rivers. It is, however, considerably warmer and saltier than the Arctic Sea. Winter temperatures in the Norwegian Current are typically between 2 and 5 degrees Celsius, whereas the temperature of the Atlantic water exceeds 6 degrees Celsius. Norwegian coastal waters are dominated by two main water masses, the Norwegian Coastal Current and the North Atlantic Drift Water. As the Norwegian Coastal Current moves northward, North Atlantic Drift Water is mixed in, raising the salinity. The current is both wind-driven, piling up of water along the Norwegian coast by southwesterly winds, and also driven by its salinity distribution, which in turn creates density gradients properties. Salinity. The Norwegian Coastal Current is a wedge-shaped current that has varying salinity and temperature characteristics, and thus densities. The volume of freshwater inputs is greatest in the summer months and smaller during the winter months, contributing to the variability in salinity. On average, it has a salinity of about 34.5 psu. The near coastal waters have a slightly lower salinity. The current's boundary to the North Atlantic Drift is marked by a slightly higher salinity, 35 ppt. Temperature. The average winter temperature of the Norwegian Coastal Current is about 3.5 degrees Celsius and ranges from 2 to 5 degrees Celsius, while in summer the temperature of the current is warmer as the tributary sources are warmed up. Velocity. Although there is much variability in the current's velocities, ranging from as little as 20 centimeters per second to 100 centimeters per second at its maximum, it is characterized by a velocity of 30 centimeters per second. Effects on climate. A mechanism of exchange of energy between the atmosphere and the surface waters of the Atlantic Ocean, Norwegian Coastal Current, is very important to the climate of Norway. In the winter time, there is a release of heat from the ocean to the overlying air masses. These air masses generally flow in the direction of northeast, thereby warming the adjacent land masses, especially the coastal regions. In the summer, the effect is actually reversed. Warm air masses above the Atlantic Ocean will transfer heat to the underlying cooler ocean. This results in cooler air masses reaching the Scandinavian peninsula, thereby cooling it down in the summer months, especially the coastal regions. Hence, the Atlantic Ocean and the nearby coastal waters have a moderating effect on the extremes of temperature in Norway, making warmer in the winter and cooler in the summer. The same effect is very pronounced at Iceland. To a slight extent, the Norwegian Coastal Current is conveying warmer water into the Barents Sea, decreasing the amount of ice that will form there. In this perspective, the effect of the North Atlantic Drift is much larger. Fisheries effects. The current brings nutrient-rich water along the coast of Norway, and with it rich fisheries of cod, herring, and capelin. Wind-driven upwelling along the Strait of Skagerrak brings abundant nutrients to the surface, which are then carried along the coastline. Norway has one of the biggest fishing industries in the world, harvesting an average of 3 million metric tons of fish each year. The Norwegian coast is also an important spawning ground for many of the commercial fishers. Global climate change. The 1990s were an exceptional decade for interannual climate variations in Norway. The temperatures were, on average, warmer, producing wet, warm winters and hot summers in Norway. This has led to increased precipitation extremes and changes in fish stocks. Increased atmospheric temperatures due to global climate change cause strong southwesterly winds to pile water up along the Norwegian Norwegian coast. The pressure difference creates storm surges that have increased coastal flooding in recent years. Temperatures have also been rising in the deep layers of Norwegian coastal waters. Increasing temperatures cause a decrease in sea ice, supplying the Norwegian Sea with greater amounts of fresh water and lowering the salinities overall. This decrease in salinity could cause changes in the rate at which bottom water form. If the rate of the formation of bottom water is slowed, then the entire inward flow of the North Atlantic drift to the Arctic Ocean may be slowed down. Anyway, increased warming of the North Atlantic drift is a much larger contributor to the inhibition of formation of sea ice in the Arctic than the contribution from the Norwegian coastal current. Hence, the impact of the Norwegian coastal current on climate change is relatively small.